Alright, so in this video we're talking about oxidation numbers, also called oxidation states, and determining the oxidation states of uncombined elements and elements in compounds and polyatomic ions. Oxidation state is a number given to an atom to show the number of electrons that were lost or gained in forming a compound. In a compound or polyatomic ion, it's the charge an atom would have if all bonds were ionic. Oxidation and reduction can be considered in terms of oxygen gain, hydrogen loss, much more usually in terms of electron transfer, or which goes hand in hand with transfer of electrons, a change in oxidation number. Oxidation is loss of electrons. Reduction is gain of electrons. A lot of people remember that by oil rig, but if you think about it, gaining electrons always leads to a reduction in charge. Electrons are negative. If they are gained, charge goes down. Oxidation, of course, is the opposite. An oxidizing agent causes oxidation and is itself reduced. It's a species which gains electrons. It oxidizes other species and so is reduced. Examples would be oxygen, fluorine, commonly acidified potassium manganate 7 solution and acidified potassium dichromate 6 solution. We'll be coming across those again. A reducing agent is a species which donates electrons. It reduces another species and so it is oxidized. Examples: carbon, carbon monoxide, potassium, hydrogen sulfide, sulfur dioxide, and zinc. Oxidation states are always shown with a plus or minus sign followed by a number. It's as if the nature of the charge is more important than the size of the charge. And our terms, oxidation number and oxidation state, are both acceptable. Naming polyatomic anions. We use oxidation numbers in Roman numerals. Now, common names are acceptable, but I would suggest that the use of oxidation numbers in Roman numerals are more useful. NO3-, the nitrate, or the nitrate 5 ion. Nitrate 5 comes about because we would always consider oxygen, group 16, to be -2. That's -6 for the 3 oxygens. The ion itself ends up as being -1. Nitrogen must be +5. Nitrite, NO2-, often called a nitrate 3. Oxygen again, always -2. That's -4 for the 2 oxygens. The ion itself is -1 overall. Nitrogen must be +3. Sulfate, SO4 -2. I could call it sulfate, that's its common name, but really, if I look at sulfur, 4 oxygens are involved in that anion. That's -8. Negative charge overall is -2. Sulfate must be +6. Sulfite, a common name for SO3 -2. It's the sulfate 4 because, again, oxygen -2, 3 of them, that's -6 altogether. The overall charge of the ion is -2, sulfur must be +4. And oxidation states can be used to analyze redox reactions. In a reaction, if there's a change in oxidation state of any element, there must be a change in another element. I'm saying that whether the elements are combined with other elements in a molecule or polyatomic ion, or whether they're as the element itself. Something is going to be oxidized, another is reduced, if there's a change in oxidation state. And when there is a change in oxidation state, the reaction is redox. Now, finding the oxidation state of an atom in an ion or compound. Oxidation state of a simple ion is the same as the charge on the ion. So, oxidation, as we said already, is accompanied by an increase in oxidation state. Fe plus 2 going to Fe plus 3, oxidation. Reduction, accompanied by a decrease. Chlorine starting off as the element, given an oxidation state of 0, no charge, going to -1 is reduction. Oxidation state of a central atom in a polyatomic ion, e.g. the sulfate ion, is equal to the charge that the element would have if it were a simple ion and not bonded to other species. Once again, oxygen is -2. 4 oxygen atoms have a combined oxidation state of -8. The sulfur must be +6 for the ion to have an overall charge of -2. Oxidation states can be used to help us decide whether an atom has been oxidized or reduced. Again, a reducing agent causes reduction and is oxidized itself. An oxidizing agent causes oxidation and is reduced itself. Useful rules. Uncombined elements always given an oxidation state of 0. Combined oxygen, -2. Very, very, very unusually. But worth noting, if we get peroxides like hydrogen peroxide, H2O2, it's -1. Combined hydrogen, always given an oxidation state as +1. And again, very unusually, but in metal hydrides, it's -1. Combined chlorine, group 17, -1, except when it's combined with oxygen. Group 1 metals in compounds +1. Group 2 metals in compounds +2. So if I'm asked to determine the oxidation state of nitrogen in HNO3, the overall charge is 0. The oxidation state of hydrogen plus the oxidation state of nitrogen, and 3 times, because it's HNO3, 3 times the oxidation state of oxygen must all come to 0. Hydrogen, as we've seen, is +1. My nitrogen, I'm finding out. My oxygens, 3 of them, all -2. Means the nitrogen must be +5. Oxidation state of nitrogen +5. In the dichromate ion, Cr2O7 -2. Overall charge is -2. It can be deduced that chromium, there are 2 chromium atoms there. Twice the oxidation state of chromium plus 7 times the oxidation state of oxygen comes to the overall charge -2. My 2 chromiums plus 7 times -2 gives the overall charge of -2. 2 chromiums are +12. Each chromium has an oxidation state of +6. A moment to work out the oxidation number of the underlined atom in each of the following. Well, I've done that by actually naming them. Sulfate 6. Each oxygen, -2. That's -8. Overall charge, -2. Sulfur must be +6. NO3 minus. The nitrate 5 ion. Each oxygen, -2. That's -6. -1 overall. Nitrogen must be +5. Chlorate anion. Each oxygen, -2. That's -6. Overall charge, -1. Chlorine must be +5. 5. Remember we said the oxidation state of chlorine always -1 unless combined with oxygen, as it is again here. Oxygen -2, overall charge -1, chlorine here must be +1, chlorate 1, and phosphorus in PO4 -3. PO4 -3. I've written 3 minus, should be -3. My bad. Okay, so I've got 4 oxygens, -2 for each, that's -8, -3 overall, phosphorus must be +5. The names of these, a moment to think, based on what we've just looked at. And we come to manganate 7, chromate 6, dichromate 6. The oxidation state of an element is always 0. It's one of the things I always look for in a redox reaction. Is there an element present? If there is, it's redox, as we shall see. There's no overall charge and nothing bonded to the atom if it's an element. Oxidation state must be 0. Any reaction involving an element as reactant or product must be redox. If the element started off or ended up with oxidation state 0, it's going to be something else. On the other side of the equation, it's changed. Oxidation state changes, it's redox. Questions to end. What's the correct definition of oxidation? Well, reduction is the gain of electrons leading to a reduction in charge. Oxidation is the loss of electrons and an increase in oxidation number, that's C. What could be reduced to form NO2? Please don't look below. Now, if I look at this, the oxidation state of nitrogen in NO2 is +4, because the oxidation state of oxygen is taken as -2. We've got to be considering that nitrogen. Oxidation number of nitrogen in NO2 is +4. I'm looking immediately. Is there an option, A, B, C, D, where there are more oxygens present? Because oxygen is always -2. Something else must compensate. And that takes me to B. To be reduced to +4, it must start in a higher oxidation state. In HNO3, it's 5. HNO2, +3. Got by considering all of the oxygens -2, hydrogens +1. I want to say it again because I think it's so important. In N2, it's 0. Finally, what happens to the manganese in the following reaction? We can do this by considering oxidation number. Manganese starts off as MnO4-. Oxidation number starts off as +7. Ends as +2. It's decreased. I almost typed it's been reduced. That's reduction. And my oxidation number has gone down. So B. And the change in bromine. When bromate ions react to form bromine. No prizes for getting the oxidation state of bromine as 0. So in the bromate anion, it started off as +5. Each of the oxygens -2, that's -6. The anion -1 overall. Bromine must have been +5. If it's gone from +5 to 0, it's been reduced. Takes us to B again. Hoping that was useful, and if it was, please hit the like button, subscribe for more content. Thank you.